Alright, so this lesson what I'd like to talk about is rate and integration. From the previous lessons, we'll talk about rate and differentiations. So in many situations, the rate, which is dq over dt or dp over dt or dv over dt, at which the quantity q or p or v is changing. So the given information is, you know what's dq or dq over dt, dp over dt, so you know that. But you don't know about the original function, v or q or p. But then what we can do is with the original function can be found by integration, right? And then we can use the boundary condition or the initial condition to evaluate the constant of integration after we finish that. So we're going to today we're going to look at about maybe 4 questions, and I would like to show how to do questions when we're dealing with integrations. Okay, so the first question says, water is flowing out of a tank at a rate of dv over dt is equal to 10t minus 250. So dv over dt is the rate of flow or flow rate. Alright, so where V is the volume in liters remaining in the tank at any given time, t minutes after the time 0. Okay. Alright, so the first question asks you, when does the water stop flowing? Now, the word stop means there is no movement, alright? So that just means that dv over dt is equal to 0. Alright, so that just means there is no motion, there's no flow rate, the flow rate is equivalent to 0. And the question asks you when, so basically the first question is really easy to understand. We let dv over dt equals to 0, and we basically solve an equation here. Alright, so that's a pretty easy question to deal with. And then all you have to do now is simply find the answer, solve the equation. So 10t is equal to 250, t is equal to 25. And then let's have a look at the unit. The unit is minute, so 25 minutes later. Alright, so the first one, straightforward, very easy. Second question, given that the tank still has 20 liters left when the water stop flow. Okay, from this information, I will write down V, the volume, is equal to 20 liters when the time is equal to 25 minutes. All right, something that we found out before from question A. Then the question says, show that the volume V at any given time is equivalent to this expression there. Well, that just means that they ask you to integrate, because previously you have dv over dt. Now they ask you to work out what's v in terms of t. Alright, and then here is the given information that you can use to find the value of c. Okay, so let's do the question part B. Alright, so B. dv over dt is equal to 10t minus 250. So what we need to do now is we just need to integrate. So v is equal to integrate 10t minus 250 dt. Alright, so it's pretty easy integration that we can do it very quickly. 5t squared minus 250t plus c. Alright, and that's the v. Alright, that's the volume. Now what we need to do is to work out what is the value of a c. Use the given information we have. So we're going to, we know v is equal to 20 when t equals to 25 minutes. So what we need to do now is just do a substitution. 20 is equal to 5 times by 25 squared minus 250 times by 25 plus c. Okay, and if we use a calculator to work out the answer, I'm pretty sure it will be the answer that we need to get for the question. Alright, so the answer we'll get here is 3,145. And let's have a look at what the number here is. Alright, yes, that's the correct answer here. Alright, so v is equal to 5t squared minus 250t plus 3,145. Alright, so the last one is really easy. How much water was initially in the tank? Well, you need to understand what this means by initially. Right? Initially means the time is equal to 0. So once we have the function here, then all we need to do now is, let's just write this one down first. So v is equal to 5t squared minus 250t plus 3,145. Alright, so the part C is really easy. You're finding the initial time, alright? So the initial time is t equal to 0. You're finding the initial volume. So when t equals to 0, the initial volume is 0 minus 0 plus 3,145. And that becomes 3,145 litre of water. Okay, so that's how we do this first question. It's a really simple, easy question. As long as you understand and be able to identify the key information from the question, then you should be able to just integrate, do some substitution to work out the value of C, and complete the question. Quite an easy question. Okay, I'm going to move on to the second question. Okay, so let's have a look at this question here. Let's just read the question first. A ball is falling through the air and experience an air resistance. Its velocity in meters per second at given at time t is given by this expression here. Okay, so dx over dt is the velocity, and it's in terms of an exponential function, where x is the height above the ground. Okay, x is just the height, and t is the time. Okay, per second, so t is in terms of second. All right, now what does the question ask us to do? What is the initial speed? Again, previous question, initial means when t equals to 0, and the question asks us for initial speed. All right, initial speed. So initial speed. Okay, so how about we just do some substitution to work out initial speed, because dx over dt, all right, is changing distance over changing time, and that's the velocity. Okay. All right, so let's do a substitution. So that becomes 250 brackets e to the power of 0, because when you substitute t equal to 0, it's just equal to 0 there, minus 1. And that becomes 250 times by 1 minus 1, and which is equal to 0 at the end. So the initial speed is equal to 0. All right, it's not moving initially. All right, question B. What is the eventual speed? Okay, so the word eventual means when t approaches to infinitively large, okay? So like infinite. And the question asks you to work out the speed. All right, so how do we do that? Still do the same thing. dx over dt is equal to 250, but this time we're going to substitute infinitive, all right, a positive infinitive into as a t. Okay. Minus 1 is equal to 250 times e to the power of negative infinitive minus 1. Now, what is negative infinitive? As a power, that means 1 over e to the power of infinitive. And then if you do the calculation, 1 over infinitive, because 1 over e to the power of infinitive is equivalent to 1 over infinitive. And then a 1 over infinitive means the denominator becomes extremely large, and you've got 1 divided by an extremely large number. That just means it's equal to 0. So you've got 250 minus 1, okay? Because 0 minus 1 is minus 1. And that gives you negative 250. So here's the answer, right? But the problem with that is we know the speed is never going to be a negative number. It's the velocity. However, that dx over dt, oops, that should be dt here. That dx over dt is the velocity, all right? But the question asks us to find the speed. So what we need to do now is basically just put absolute value around. So you can just turn everything into positive, and even you get a negative answer here, the speed is just equal to positive 250 meters per second. If you don't want to put absolute value, that's okay, all right? As long as you justify your answer at the end, all right, by writing a sentence, you just say the speed is equal to 250 per second. That's fine, totally okay. All right, so that's part B. Let's have a look at what's part C. Part C, find x as a function of time. If it's the initial 200 meters above the ground, initially 200 meters above the ground. All right, so let's have a look. Initially, t equals to 0, 200 meters, x equals to 200. And the question asks you to find x in terms of the time. So how do we do it? Well, obviously, this time is integration. All right, so let's just do the C here. So dx over dt is equal to 250 e to the power of negative 0.2t minus 1. Now what we need to do is we need to integrate this expression. So x is equal to integrate 250 e to the power of negative 0.2t minus 1 dt. Okay, it's not a very easy or straightforward integration to do. So how about I'm just going to move the 250 outside. All right, now what do? We need to integrate this term here. We're going to use the reverse channel. What we need is, at front, we need negative 0.2. So outside, I need 1 over negative 0.2. So negative 250 over negative... Okay, let's start again, okay? That would be 250 over negative 0.2. We will change this one later, all right? But at this stage, this is what I'm going to write. Okay, and then when we integrate that, it's just equal to e to the power of negative 0.2t. Remember, you can put a bracket. Okay, you can put a bracket. Once you finish that, okay, and we need to integrate the negative 1. So when we integrate negative 1, it's just equals to t. But please remember, we still have and then 250 right in front. So that's why it's minus 250t. Okay? All right, plus c at the end. So that's how you integrate it using the reverse channel. Now, for those of you who still have a problem with integration, just remember here I need to put negative 0.2. So that means outside I need to add negative 0.2 as the denominator to cancel that negative 0.2. Okay, all right, so what we can do now is use the calculator to work out the value of c by substituting the initial condition. All right, so when t equals to 0, x equals to 200. All right, so let's do a substitution to work out what is the value of c. So that becomes 200 is equal to 250 over negative 0.2. And then e to the power of 0 means it's just equal to 1. Okay, minus 0 plus c. Okay, so c is equal to 200 minus 250 over negative 0.2. Right, now you can use your calculator to work out the answer here. The answer is equal to 1,450. Once you get this answer here, then you can just substitute this value back to the original equation and you will get the final answer. So x is equal to 250 over negative 0.2 bracket e to the power of negative 0.2t minus 250t plus 1,450. Now, of course, it's better to write the answer not like this because it's really weird to write a fraction in this form where you have decimal numbers in it. So that becomes 1,250 negative e to the power of negative 0.2t minus 250t plus 1,450, and that's the value of x. Okay, so that's how you solve this question here. So as you can see, this question, it is slightly harder than the previous one just because the integration is a bit difficult to do. But the rest of the stuff is quite easy. You do need to understand what is meant by initial. Initial means t equals to 0, and what is meant by eventual. It just means when t approaches to infinity, when the time passes. Okay, and then when t becomes infinitive large, what is the value of x? Okay, all right. So that's question. The second question. We're going to move on to the next one. Okay, this question. Let's read this question. It's a long question here. All right, it's about a flow of water again. So the flow of water into a small dam over the course of the year varies with time, and it's approximately by dw over dt is equal to 1.2 minus cosine squared pi over 12t. Now the reason it's hard is because it's a trigonometry function here. And that's why it's hard. Where W is the volume of water in the dam measured in thousands of cubic meters, and T is measured in months from the beginning of January. Alright, so that's interesting. It's in months from the beginning of January. So that might ask us to, oh yes, they do ask us when does this happen. Alright, so that's a really interesting one. If you see something like this, I can guess that the next part of the question will ask you for the time or the date. Alright, so let's have a look at the first question here. What is the maximum flow rate? Maximum flow rate into the dam, and when does this happen? Alright, so we've got two pieces of information. Maximum flow rate. When you see maximum, minimum, this kind of wording here, all right, the first reaction you need to have is differentiation. So the maximum flow rate, well, but what is the flow rate? Well, that's the flow rate. So maximum flow rate means you're going to differentiate again. Okay, you're going to differentiate that again, and you're going to let that equals to 0 to work out what is the maximum flow rate, sorry. Right, so this is a bit tricky here, because the question didn't ask you for the maximum amount of water, all right? It didn't ask you for the maximum volume of water, it asked you for the maximum flow rate. So we are going to start with this dw over dt equation. And we are going to differentiate that one more time. Okay, so d squared w over dt squared. I'm going to differentiate that. Well, when you differentiate 1.2, it disappeared. All right, now you just have to differentiate that one here. You need to basically treat this one as like a bracket. Okay, so how about I'm just going to rewrite this so it'll be easier for everyone to see. So that will be cosine pi over 12t bracket square. So I guess that way it's a bit easier for everyone to see the derivative happening here. So it's a channel, so put a 2 in the front. Minus 2 by 1. Multiplied by the derivative of what's inside. And the derivative of what's inside is minus sine pi over 12t. Times by another chain rule, what's the derivative of pi over 12t? That's pi over 12. Alright, okay. Now, have you noticed that you can actually cancel this negative and negative there? Alright, so that becomes positive. And then, it's actually, I'm just going to rewrite this, okay? And hopefully you can see, this is a trig identity formula. And I hope you realize this part is 2 sine A cos A. This kind of style, okay? So that is a double angle formula for sine. Alright, so let's write down pi on 2 outside. And it's a double angle formula, which means 2 times by pi over 12t. So that becomes pi over 2 sine pi over 6t. Okay. Alright, so we just finished differentiating this one more time. Okay, once we finish that, we're going to let this derivative equal to 0. Remember, we're finding the maximum, the flow rate. So we're going to let d squared w over dt squared equals to 0. Basically, you're treating this as like you're differentiating. That's the first derivative of dw over dt. So the first derivative help us to find the turning point, to determine the nature of the turning point. We're finding the maximum value here, so, you know. Okay, so we let that equal to 0. So pi over 2 sine bracket pi over 6t is equal to 0. So we basically solve this equation. Pi over 6t is equal to 0, and the second one is pi. So t is equal to 0, and t is equal to pi times by 6 over pi, which is 6. Alright, so 0 and 6 moles. Okay, now of course, right now, you can't really decide whether this is the maximum or the minimum, okay, rate of flow rate. So what we need to do is you can differentiate one more time, okay, to get the third derivative, which is equivalent to like the second derivative, and you can prove it by saying that when t equal to 6, it is the maximum value, okay? So to save for the time here, I'm not going to do that, but you do need to, you know, either use your table of values to check the nature of the stationary point, remember, or what you can do is you can use the third derivative to check the nature of the turning point as well, all right? But what we want is a maximum turning point. Okay, all right, so when t equal to 6, that gives the maximum flow rate. But let's have a look at the question. The question says, when does this happen? T equal to 6, and what's t? T is measured in months. So when t equals to 6, from the beginning of the January, so that means the flow rate is maximum at the beginning of July. Okay, so you can't just answer, oh, when t equal to 6, that's the answer, all right? So you have to actually go back to the question. The maximum flow rate happens at the beginning of July. Or the flow rate is maximum at the beginning of July. So after 6 months later. Okay, so that's just the first question. Okay, oops, that's just the first one. All right, now let's have a look at the second question here. Given that the dam is initially empty, find the W. Okay, initially empty. Very important, that information tells us when initially means when t equals to 0, empty means W equals to 0. Another question asks us to find W, which means just asks us to find the equation of, or the function, W in terms of time. Alright, so let's just create another page. Let's do that. Alright, so part B. Firstly, the equation dw over dt is 1.2 minus cosine square pi over 12t. And let's just write down everything we know. When t equals to 0, w equals to 0. Okay. All right. What else we need? That's about it. All right. So all we need to do is now integration. So w is equal to integrate 1.2 minus cos bracket pi on 12 t. Let's put a square here. And dt. Now, how do we integrate these? So the question comes to, how do we integrate cosine square x? Not really sure if you still remember this, but we've got a formula, cosine squared x. We need to, if you want to integrate this, we need to change that into half brackets 1 plus cos 2x to integrate these. So now it's very similar to this question here. We have integrate cosine pi over 12t and square dt. And all we need to do is we need to change that into half bracket 1 plus cosine 2 times by pi over 12, which is pi over 6t. So that's what we need to, alright, that's what we need to get to. Okay, so w is equal to, we can just integrate this one straight away. So that becomes 1.2t minus half bracket, half integral 1 plus cos pi on 6t dt. That's what you need to get to. Alright, sorry, something that's a bit tricky. Alright, now so w is equal to 1.2t minus half bracket, and now we need to just integrate 1 by 1 t. Okay, and when you integrate cosine pi on 6t, it is equal to 6 over pi sine pi over 6t. Okay, 6 over pi and sine pi over 6t. Alright, plus c. Okay, alright, so now what we need to do is I'm just going to substitute. Alright, when t equals to 0, w equals to 0. So let's substitute everything inside to work out what's t. So what's c, sorry. So that's 0. 1.2 times by 0 is equal to 0. Minus half bracket 0 plus 6 over pi sine 0. And we know what sine 0. Sine 0 is equal to 0. So it looks like everything is equal to 0. So that just means c is equal to 0. Okay. Alright, so now for this one, I'm just going to rewrite this one so it becomes a little bit better. So now final answer, w is equal to 1.2t minus 1.2, so half t, minus 3 over pi sine pi on 6t. Next, 1.2 minus 0.5 is 0.7 t minus 3 over pi sine pi on 6t. Okay, that's what w is. So now I have a final answer for the equation of w. Okay, so w is finished. Let's go back to the previous page and let's have a look at what's the next part of the question asking us. The capacity of the dam is 25,200 cubic meter. Okay, cubic meters. Show that it will be full in 3 years. In 3 years will be full. Okay. So how do we do it? In 3 years will be 4. All right, so we already have this equation here. So all we need to do is just simply substitute. How about we substitute t equals to 3 and see what's happening? All right, so w is equal to 0.7 times by 3 minus 3 over pi sine pi on 2. So that becomes 2.1. 2.1. Before I substitute 3, let's see what's t in terms of. Oh, t is in terms of months. So we can't substitute t equal to 3. Okay, that's an interesting one. All right, I almost made another mistake here. That's in terms of year. What we need to do is times this number by 12. So it is the correct answer, right? So we need to times here by 12 as well. Okay, you can't just simply times by 3. Okay, that's the problem. Okay, almost made a mistake. So times by 12. All right, let's just do that one more time using my calculator. Okay, so this one is 25.2 and minus, let's see what's sine 6 pi. And sine 6 pi, I guess it's equal to 0, so minus 0. Okay, so that gives you 25.2. Okay, 25.2. But what's the unit for W? The unit for W is measured in thousands of cubic meters. So what do we do? Okay, so 25.2 is in terms of tons. Okay, so that's 25.2 tons. And then that becomes 25.2 times by 1,000. That gives you 25,200 cube meters. Okay, all right. Finally, we've just finished that question there. All right. So now, I think there is one little problem with this question, okay? The reason for that is because the question says the capacity of the dam is 25,200 meter cube, right? Our answer we get is 25.2. So I'm assuming that's 25.2 tons, right? But this is not right. It looks like the question is not, the wording of the question, or especially the unit, is not right, okay? But doesn't matter, okay? As long as the idea behind we know, like how to do the substitution, whether this is correct or not, this is the most important. But I personally believe the question, especially when they talk about, W is the volume of the water in the dam, measured in thousands for cubic meters. So this is really confusing. But then the next part it says the capacity of the dam is 25,200 meter cube. And the answer we get is the ton. So it's really interesting, all right? And I don't think the wording is that correct. But anyway, as long as we know the idea behind how do we do the question, that should be fine. Okay, all right. So now let's finally move on to the last question. Well, I believe that question is even harder than the previous one. Okay, so how do we do this one here? So let's just read this question one more time. Sand is poured. Alright, sand is poured onto the top of a pile in the shape of a cone at a rate of 0.5 meter cube per second. Alright, so that's a rate, and we're looking for the volume rate. Okay, so dV over dt. So that's dV over dt. The apex angle of the cone remain constant at 90 degrees, and let the base radius r and let the height to be h. Find the volume of the cone and show that it is 1/4 of the volume of a sphere at the same radius. Wow. Okay. So what we need to do is draw a diagram. Here's a cone. The radius is equal to r. The height is equal to h. Now, the apex is 90 degrees. So that basically tells you this angle here is 90 degrees. All right, let's zoom in here. That's 90 degrees. That tells you if that angle is 90 degrees, then, then if I just break down this into a right angle triangle, all right, so imagine this is the cone here, okay, but we're just looking and pay attention to the right angle triangles here. Now, if the apex is 90 degrees, that means this angle here is 45 degrees. And we know that's 90 degrees here, so that means that's also 45 degrees. So that tells you this is an isosceles right angle triangle, which means if the radius is r and h is the height, then they must be equal to each other. Okay? So that's a very important information that you do need to know before we can actually start to solve this question here. Alright, so let's see what this question asks us to do one more time. 1/4 of the volume of the sphere. Okay, so we're going to find the volume of the cone. Alright, so let's find the volume of the cone first. Volume of the cone is 1/3 pi r squared, which is the base area, times by the height. But now, because the height and the radius are equal to each other, so h is equal to r. So can we just replace h by r? So we get v equals to 1/3 pi r squared times by r, and is equal to 1/3 pi r cubed. And that is the volume of the cone. Let's just write down the volume of the cone here. Alright, so the next one is the volume of a sphere. Alright, from the memory, volume of a sphere is 4/3 pi r cubed. So now it's really clear. Volume of a cone is 1/3, and the volume of a sphere is 4/3. And if you find the ratio between these two, it is 4 times, or you can say the cone is, the volume of a cone is 1/4 of the volume of a sphere. Alright, so that's pretty easy now. But, if you want to show working out, it's just going to VC divided by VS is 1/3 pi r cubed divided by 4/3 pi r cubed, which is equal to 1/3 divided by 4/3, and the answer is 1/4. Okay. Alright, so the first question looks pretty easy. Next one. Find the rate of changing radius. Rate of changing radius. So we're going to find dr over dt of the cone as a function of r. Okay, as a function of r. So that should be okay. It should be quite easy to do as long as we know the formula. So we know that VC is equal to 1/3 of pi r cubed. Then if I want to work out what's dVc over dt, because that's a change in volume of a cone over change in time, and that is equal to, when you differentiate that, that becomes 1/3 times by 3 pi r squared dr over dt. Okay, dr over dt. Alright, so now what is dv over dt? dv over dt, according to the question previously, it says it's equal to 0.5. So we can just do a substitution inside. 0.5 is equal to pi r square and times by dr over dt. We are finding dr over dt in terms of r, so now dr over dt is equal to half divided by pi r square, which is equal to 1/2 pi r square. Okay, so that's what dr over dt is equal to. Alright, so part B has finished. Now let's move on to part C. By taking reciprocals and integrating, finding t as a function of r, given that the initial radius is 10. Okay, we need to find t as a function of r. So we need to find the tr function. Okay, how do we do it? Alright, let's do it here. We know dr over dt is equal to 1/2 pi r squared. What we need to do is to change this derivative function into t in terms of r function. Alright? But before we do that, if you pay attention to the denominator, the variable is t, but on the right hand side the variable is r. You can't really integrate like this. So what we need to do is we need to change the order. So we need to do the reciprocal of both sides. That's dt over dr. So that becomes 2 pi r squared. All right, so we'll take the reciprocal of both sides, and now as you can see, the denominator is in terms of r, and on the right hand side it's also r. So now t is equal to integrate 2 pi r squared dr, and t is equal to 2 over 3 pi r cubed plus c. Alright, so let's have a look at initial condition. Initial condition is initially the radius is equal to 10. Okay, so when t equals to 0, radius is equal to 10. 0 is equal to, alright, from here we should be able to work out what is the value of c. 2 pi times by 10 to the power 3 over 3 plus c. So c is equal to negative 2 pi times 10 to the power 3 over 3. Alright, and then of course you can actually replace the c by the value here to get to the final answer. Okay, so that's part C finished. Now the last question here is find how long it takes, correct to the nearest second, for the pile to grow another 2 meters in the height. Okay. So what we need to do now is to find how long it takes. Alright, how long it takes, corrected to the nearest second, for the pi to grow another 2 meters in the height. Okay, another 2 meters in the height. So how do we do it? Previously, the height, or so because we know the radius is equal to the height, so previously the radius, or initially the radius is equal to 10 meters, means the height is equal to 10 meters. To grow another 2 meters means the height is equal to 12, alright, meters. So this is really important. So we're thinking about when the height was 10 before, now to change when the height is equal to 12 meters, and we're going to find the time difference. Okay, and that's what we need to do. We're going to find the time difference. So how do we do it? Well, we have this equation here. This equation here. For this equation, all right, we should be able to work out the time by doing the substitution. All right, so let me just create the page. And let's just write down the equation we had previously. T is equal to 2 pi r cubed over 3. Let's check one more time. Yep, plus c, or minus 2 pi times 10 to the power 3 over 3. Okay. Alright, so if we can factorize, that becomes 2 pi over 3 bracket r cubed minus 10 to the power 3. So that's just a bit easier to do the calculation. Alright, so we know that t is equal to, the height is equal to radius. So r is equal to h. We're going to find the time 1 when h is equal to 10. And we're going to find the time 2 when h is equal to 12. And then we can find the time difference to solve the question. Alright, so we know the time taken. So basically now it just becomes the substitution. Alright, so we know that's equal to r, we know that's equal to r. So t1 is equal to 2 pi over 3, 10 to the power 3 minus 10 to the power 3. And we know that's initially. Great, that's time equal to 0. That's really easy. T2, 2 pi over 3, 12 cube minus 10 cube. Alright, and let's use our calculator. Okay, so the answer we get is 1524.72. Let's check what's the unit. The unit is in seconds. Okay, so seconds. Alright, so the time difference is equal to 1524.72 minus 0, which is equal to 1524.72 seconds. And if you want to convert into minute, divided by 60, that becomes 25 minutes, and use the bubble key, you get 25 minutes and 25 seconds. So that's how long it takes for the radius or for the height to increase by 2 meters. Okay, alright, so these are the, how many questions I did? These are the 1, 2, 3, and 4 questions I did for the rate and integration. This takes a lot of time to do the later questions because the questions long and integration is hard, and sometimes you have to be careful about the wording. Not an easy question, but as you can see, it's all sort of like using the knowledge that you learned from integration. And basically the question is just read the question, understand it, integrate, try to get the most important part of in the question, the most important information in the question, and try to do a substitution to work out the C. Once you get the final equation, the rest of the question is just again a substitution. Alright, I hope you enjoyed the lesson. Alright, thank you.